Guess it's time to start the stream. Maybe somebody will join. If not, that's okay. So I'm trying to basically sync the Python documentation for the grammar, and I'm basically going through the docs now and rewriting the existing grammar snippets with something that's generated from the actual grammar itself. So this is something I should probably have done off stream because it's not that interesting on its own. But I haven't really looked at it over the holidays, so I will continue just where I left off last year. Right, then that was compound statements, about a third of the way through this file. Add patterns, where I've changed these patterns, pattern and close pattern. They seem to match quite nicely to the handwritten documentation that's in the docs currently. So the way I'm doing this is I'm keeping the old handwritten documentation, and below that adding the auto-generated or the one that's generated from the grammar. In the source, it looks like this. There's a production list that's there from the previous or from the existing docs, and then there's this new peg fragment directive where I say what should be documented. Wait, that's sequence pattern. Sequence pattern over here. So I say what should be documented, and the tooling picks up the definitions themselves automatically. It doesn't yet format them nicely. That's the next step. But it does include all the information we want, right? So there's this in square brackets or parentheses. There's something with a comma, maybe star pattern, and has some superfluous bracket here, but should be semantically the same. I don't know about this question mark. It seems it's not really used elsewhere in the docs, but it's handwritten, so I guess it belongs there. This is exactly the same, and this is somehow simplified in the handwritten docs. I will get to that later. Right, so yeah, this matches quite well. It's new syntax, so it didn't have time to get out of sync. I see there are mapping patterns. So there's mapping pattern. Let's see how that looks in the source. I only say I want to document mapping pattern, and it picks up double star pattern. Ooh, item. Mapping pattern seems to be complicated. So there's items pattern, which in the actual grammar it does not end with an optional comma. And there's double star pattern, which is basically the same. There's items pattern, I went through that. There's key value pattern, literal pattern or value pattern. Those are interesting. There's an expression or attribute in the auto-generated docs. There's no literal pattern. guess, in the actual grammar. Oh, there is a literal pattern, but it's not used. Where is it used? Closed pattern. Huh. Interesting discrepancy. Should probably be parentheses around this. Yep. And the formatter here is leaving them out because it's not very smart. There's adder, which is name or adder dot name. Seems to be named value pattern in the original docs. So what's value pattern in the original docs? It is adder. Okay. Value pattern is adder, but where is it used? In closed pattern. Huh. It seems the mapping pattern doesn't use value pattern anymore. I just use adder. Wonder why. But I guess that's not something I want to look at now. I'll move on. Class pattern seems to match nicely. There's name or adder. And empty parentheses. There's name or adder with positional patterns. There's name or adder with keyword patterns. So pattern arguments here is basically expanded in the actual grammar. There's positional patterns and optional keyword patterns. The whole thing is optional here with an optional trailing comma. I would like to get to this level of simplification automatically at some point. Name or adder is repeated here. I guess that's fine for now. Positional patterns are the same, keyword patterns are the same, keyword pattern is the same. So this basically matches. Next up, function definitions. There's a lot of stuff here that's probably unneeded. So instead of funcdef, this rule is now named functionDef. It has decorators. Then there's functionDef raw, which is inlined for here. It looks like there's decorators, and this decorator here is not inlined in the handwritten docs, but that's fine. Function def raw has the actual function definitions, and this one has the async version, which I think in the docs has a separate section. I will need to work around that somehow. So if I look, right, so the docs have a coroutine section which has the async function def grammar rule, and that is the same as the above except it has async. So grammar wise, this is just a function definition with an extra keyword prepended, but the docs want a separate section because the semantics are completely different. So I think what I'll do for the final version of this effort is keep the grammar in here, and then from this section either repeat it or just refer to the previous section. Right, what do we have next? There's params instead of parameter list, and parameters have slash no default, param no default, param annotation, param with default, default, start etc, param maybe default, keywords. This is very, very complicated, and I guess the handwritten documentation simplifies what it can, but this will really need either some very good simplification code, or maybe it'll only make sense with the railroad diagram. What I can do here is get rid of this bitwise OR. Bitwise OR should, so where does it come from? It comes from star expression. Do I have, oh, this, star expression is a star and then either bitwise OR or expression. But I guess bitwise OR and XOR should really go into expression here. Yeah, comparison includes this bitwise OR here. So let's go into expressions. And say that bitwise OR should be documented with a comparison, and everything else should in the end just link here. So what I need to do now is add this to this data file that'll hopefully go away eventually. Now I can regenerate the documentation and everything goes well. This bitwise OR and its bitwise XOR will disappear from here. That will not make function definitions simpler by much, but everything else here is it does relate to function definitions. There's this func type comment, which in reality is either new line type comment and an indented block, or just a type comment. And I hope this this can be simplified. Where does this func type comment appear? So it's after the colon and it can be a new line. Maybe this will need some special handling, but I'll leave that for later. I'll leave this whole thing for whenever I get to some simplification. Next up, class definitions. So we have class def. the handwritten documentation, it's decorators, class name, type parameters. There are no type parameters. Inheritance, that's the thing in parentheses, and suite. So in the actual grammar, it's either decorators and the actual definition, or just the definition without decorators. Decorators are well, there's one or more, but it's optional from here. Class def raw is the class name, type params, and instead of inheritance we have an optional list of arguments in parentheses. And these arguments might be shared. No, they're not shared with function definitions. Where are arguments used in the grammar? Class def raw has arguments. A call has arguments, right? So I would say that arguments should be documented. Well, the syntax for arguments should be documented with function calls. That's probably, well, that's definitely where users will see them first. And yeah, there's an extra name inheritance that might make it easier, but I see argument list in the old docs is also defined in expressions. So let's put arguments together with call. And I really need to start generating this automatically. So expressions. Right, so arguments should be documented in here, and everything else should just link there. Yeah, I need to run my actual tool. Let's see if that goes without errors. Sphinx is quite slow. Sphinx is slow. It needs to regenerate the whole documentation, especially after an error. Next week I should have a stronger computer that will have more cores, and maybe that'll cut the time the Sphinx needs. Anyway, so arguments should be elsewhere. That pulls in args, which should also be elsewhere, and that pulls in start expression, keyword arguments, and that should all go in this. So hopefully that'll cut down on the grammar here. Make it just class def decorators and class def raw. Build succeeded. No. Well, argument should be here and should be top level. Wonder what I'm doing wrong. I have so many ideas for better tooling. Alright, now I get to coroutines. So async funcdef is defined with the real function definition. It just has this async. Grammar-wise, it's very similar. The same for async for and async with. So in the final version of this, I'll just reference the normal function definition there. And I'm getting to type parameter lists. This is new in 3.12. how does that look? So you can, after a class name or I think a type declaration, you can have square brackets, the type parameter, which can be a type variable tuple, or param specification, and that's identifier colon expression, or the identifier with stars. So in the actual grammar, it's quite similar. So there's type param, comma, type param. Here it's done with the syntax that says it's type param separated by comma, and there's an optional comma at the end. I wonder if this could get its own simplified syntax, because you often have this sequence of stuff separated by commas and then an optional comma at the end. It's kind of repeated here, but usually it's just a comma, so it's probably not that distracting, or it's not that bad that this repeats. Anyway, type param is the name with a type parameter bound, which is the colon expression. That's optional. Or it can be a star name colon expression, and that's actually missing from this grammar here. Or it can be star name without the colon expression, and the same thing with the double stars. So yeah, there's a bug in the current documentation. This is missing the colon expression. I wonder if that's worth reporting. Probably not, since I'll be replacing the whole thing. This grammar is not really trustworthy anyway. That looks good. Generic functions. This doesn't really have grammar definitions. They're all up there somewhere. Generic type aliases. And that's it for compound statements. So, did the function call get simplified here? Still has bitwise, bitwise or some reason. As my tooling is getting really unreliable here. I have ideas how to improve it, but first I want to go through the documentation, see what really should be documented and how, and then I'll get to simplification and improving the tooling. Anyway, so that's compound statements. Now I get to simple statements. So a simple statement is one of these things. In the actual grammar, there's a list of simple statements, or a sequence of simple statements, defined as simple statement with a new line, or simple statements separated by a semicolon, optionally terminated by a semicolon, and then a new line. And you can see how this grammar rule also matches these, but I guess this one's easier to evaluate, so for performance reasons it comes first. Usually you don't use semicolons in Python, so Python will first look for for a single simple statement and not consider the more complex rule. And then a simple statement is, assignment type alias, that's probably this, star expression, that's expression statement, return statement, import statement, rate, blah 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 blah. I guess that's everything here. The break and continue are just simple tokens. They don't have their own grammar rules, but otherwise it's a differently ordered list, but it should be the same, hopefully. Oh, pass is another one. Single word statement. Right, so expression statements, that doesn't have its own name in the actual grammar. That's fine. I think we can just use star expressions instead of expression statement. Assignment statements. Ooh, that's a lot. So assignment is name, optional colon. Maybe that's the target here. No. I don't see a colon here. At least there's target and target's identifier. I guess that's just missing from the current documentation. And that equals annotated right hand side. Annotated right hand side. Where do we find that? Oh, annotated assignment expressions. Right, it's so it's its own rule. It can be a yield expression or star expressions. Huh. Okay. And then we have a single target. So single target in parentheses. Single subscript attribute target. That's something dot something, or so attribute access or get item, and that can be annotated, and that's something's assigned to it. We can have star targets equals yield expression. Star expressions. This is just too complicated for my little brain, I think. I really need a railroad diagram here. Anyway, single target. This all looks related to assignment. I don't know if T primary is exclusive to assignments. T might be short for target, so that's the thing you assign to. So that's attribute access, item access, a generator expression. I guess this is a function call with a generator argument. Or this is a function call, or well, call, or atom, like a variable name or something. Okay, and that needs arguments. I think I said I want to define arguments elsewhere. So let me look why my giant command line here that I used last time doesn't work. Doc data vec top level rules txt. I touch top level components. Oh, this is the thing. In my command line that I copied from last year, I touch top level components.rst, but I should really touch everything in reference to make Sphinx regenerate the files I want to look at, rather than keeping them in the old version. And when I do that, hopefully these bitwise XOR will disappear from here as well. Once Sphinx is done. Still no? That's weird. I don't know what's happening here. Well, next step. After I go through the whole thing, I'll improve the tooling. Augmented assignment statement. Can I recognize the handwritten thing in this? So that's single target instead of aug target. Augmented assign, that's another name for augmented operator, which is one of these operators. They're not really operators. Or it can be star expressions. I guess there's parentheses missing around these. I need to format that better. Next up, what is single target? That's either a single subscript attribute target, or a simple name, or a single target in parentheses. What's a single subscript attribute target? That involves T primary, which we already saw in the in assignment. So I think T primary should be documented together with the assignment, and not anywhere else. So and I guess this, oh, where does arguments come from? That comes from this here, and arguments should be documented with calls, and that hopefully brings in all the rest. So this should be missing from here eventually. Next up, annotated assignment statements can have a yield expression or star expression, and this is only the annotated right hand side. I wonder if we want to put in more, and here it's in the top level rule. Maybe the grammar needs to be in this big block, and then this section should just reference it, but that will be clear once I go through the formatting simplification. A search statement looks very similar to what was there before. There's actually convention for these quote marks. The single quote marks mark keywords or operators, and the double quotes in the new grammar denote soft keywords. But the old documentation doesn't really use that convention. Then we have the pass statement, which is just pass. It doesn't have a name in the grammar. Maybe the grammar file should be changed to give it a name if there is no performance impact for that. Next up, we have the del statement, which has its own rule for targets. This T primer is shared with something else. I think I already added that. And that should hopefully make this go away. Eventually, there's del T Adam. Delete target Adam, which somehow differs from the regular Adam, and that means these del targets are different from a normal target list. And I wonder how this is different from a normal Adam, which should be defined in expressions. So that's name. Oh, this has true, false, none, which of course you cannot delete. So this is a name, something in parentheses or brackets, and here we have name and bunch of things you cannot delete, like tuples and generator expressions. So this is more complex for a reason. Now I see nobody joined the Discord, but if anybody's watching the YouTube, I need to step away for a minute, and I'll be right back. So, where was I? Delete looks good. Return looks good. Yield looks also good. Raise also fine. Break doesn't have, it's just a single word, so it doesn't have its own rule in the actual grammar. Continue, the same thing. Now import looks very complicated. So the old grammar says it's import module as identifier, comma, well, more modules. Or you can do from relative module import identifier as identifier and more identifiers. Or from relative modules import the same thing in parentheses. Or from a relative module import star. A module is identifiers separated by dots, and a relative module is the same thing with dots in front or just dots. Right, how does that work in the new grammar? So import statement is either import name or import from. So import name is import dotted as names, and dotted as names is a comma separated list of a single name, which is you import a dotted name, optionally do as name. This identifier is just the name token. Dotted name is either just the name or name with more dotted names in front. That looks good. So it's a very different way of saying the same thing. Import from. This is nice. So it starts with from, and then it, for this relative module, these dots in front are a sequence of individual dots or triple dots, because the triple dot, the ellipsis, is its own token in Python. So the tokenizer, if it sees 3 dots in a row, it'll give you the ellipsis token. If it sees 4 dots in a row, it'll probably give you these 3 the ellipsis token and a dot token. Let's try that. That might be interesting. So I think it's tokenize. Right, and it needs a file. Sorry. There. So the dot is tokenized as a single dot. If I have 2 dots in a row, it's tokenized as 2 dot operators. But if I have 3 dots in a row, it'll give me the ellipsis operator. And if I have 4, then it'll give me the 3 and the 1, and so on. Yes, might be interesting. So a sequence of these is in front of the dotted name for the relative module. Then comes import from targets. And right, and then there's the entire thing again without this dotted name, so you can import from just some dots. Basically this dotted name is optional, and hopefully I can simplify it to this being optional. Alright, import from targets is import from as names. And those are basically the same as these dotted as names and stuff. except they don't have they are simple names. They're not they don't have package names with dots in front of them. Right, so that makes sense to me. Nothing extra is there. Future statements. Do we have future statement in the grammar specification? There's no future statement, and I guess that's because it's not handled at the grammar level. If I look in the actual grammar, where's that grammar? Python.gram. Do we have any future here? No. Where is future handled? I have no idea. But there's no special grammar for future statements anymore. So I guess this will only where is this handled? Docs, not lib. Compile.c. This one. Right, so from import has a special case for if the import from name equals future. Right, so I guess the reference documentation here will say that if this this dotted name or whatever from this dotted name, if this this whole thing equals under future, then there's a special behavior for it, but it's the same on the syntax level. So I'm not adding anything here. Next up, global statement. This is more concise. Hopefully it's easier to read as well. Non-local statement is grammar-wise very similar to global. Type statement, type, instead of identifier we say name, and the rest of this is the same. So simple statements. That was a very quick run through. And now let's go on to expressions. So how do expressions work in Python? This has a syntax notes saying what the syntax is. It's extended BNF notation, and maybe that's first referenced in the lexical analysis. Anyway, this to me seems like this documentation is meant to be read in order, like chapter 6, chapter 7, chapter 8. Otherwise, you'll miss the description of the syntax. Maybe that could be handled a better way. but that's for another pass through the docs. So, most basic elements of expressions are atoms, which can be an identifier, literal, or enclosure. Identifiers are names. Right, so this is the name. Literal is one of these things. So it's a number, a complex number, strings, none, true or false. So this is all put in here. Maybe ellipses should be here as well. Huh, do the old dogs have ellipses? Nope. No, looks like it's not documented. Interesting. So this is identifier, these are literals, and enclosures are parenthesized form, list display, text display, set display. So that's the rest of these things. And a tuple is singled out here for some reason. Probably shouldn't be. Parenthesized form displays for lists. The list contains at least one comma, at least yields a tuple. And I guess the start expression then defines a tuple. An expression list containing at least one comma yields a tuple. So I guess the tuple should be defined over here with a group. Maybe this will need reorganization. Really looks out of place here. So if there's at least one comma, it's tuple, or if there's 0 commas, it's a tuple. Otherwise it would be a group. Right, so parenthesized form can be either a group or a tuple, depending on if it has a comma inside. Right, so what I'll do is document tuple in here, mark it top level. So it'll disappear from here and it'll be put together with a group, and it's in its own section. That looks best. And I guess those are all defined later. Alright, so literals. Literal can be a string, bytes, integer, float, or imaginary. Literal expression is a signed number, which is either a number or a number with minus in front. It can be complex number, which is signed real number plus imaginary number or signed real number minus imaginary number. And I think this imaginary number in the old documentation is covered in lexical analysis, which is not really true anymore. Imaginary literals. Oh, there's imaginary number, which is just a number with a J at the end. And this grammar is maybe more complex than it strictly needs to be. Because if you have a signed real number plus imaginary number, this whole thing would make a normal addition expression, and the result would be a complex number. And nowadays Python has optimization for constants, so it would probably compute this and put the result in the bytecode. But I think the reason this is done this way is to support AST.literal eval. This function this literal eval, which doesn't allow arbitrary expressions. So the expressions that we can use with the literal eval actually need to be special cased in the grammar. And I wonder if that's necessarily appropriate for the documentation. Maybe it needs a subsection here saying that, you know, complex numbers are special cased in the grammar, but really work as if this wasn't here, as if we only used imaginary numbers. But anyway, I will leave that to another pass through the documentation. For now, I think complex number is in the right place here. What's next here? We have signed real number, right, which is a number. Well, real number is just a number, and imaginary number is also just a number. But I guess they have let's look at the real grammar here for this. That's imaginary number as pigeon ensure imaginary. So it lexically, an imaginary number is just a number, but there's a function that I assume raises an error if it's not an imaginary number, if it doesn't have the J at the end. And I'm sure there's some performance reasoning behind that, but it doesn't really help clarity in the documentation. I guess it will need some prose later. Let me add a note in here for myself when I go back to this. So this is in literals. So let's say to do explain the non-obvious and the non-obvious grammar rules would be complex number, real number, and imaginary number. So complex number, real number, imaginary number. And I need to literal expert. Right, what's next? Strings. Strings are concatenated by putting them next to each other, and they can be f strings or normal strings, and this string is just a token of the same name. But f strings are composed of f string start, f string middle, f string end, and that ties in with lexical analysis, where I think it's currently documented. We have string here, formatted string literals. Right, so f string has this handwritten documentation written for tokens, and I think that's currently a bit out of date, as it has f string as the whole thing, but the real grammar currently has f string start tokens and f string end tokens, and the f string middle has f string middle token, which is a literal string part of the F string. Let's see how the tokenizer will tokenize this. So f, an empty string, is just tokenized as string. Let's make sure I'm using the right Python. Right, so this changed in 3.12 actually. So right now f strings are tokenized as f string start, f string middle, and f string end. If there's nothing in here, then I'll just have the start and end. And if there's an expression in here, there's f string start, and then there's this operator, some kind of expression, well, tokens for an expression, this closing operator, and then an f string end. This f string should contain the quotes that I'm using, and the tokenizer will actually ensure that the quotes match. So if I put some other kind of ending quotes in here, it'll get recognized as f-string middle because currently we're in this triple quoted string, right? So the tokenizer has some logic or has some state that makes it close the parentheses properly. So actually inside here I can have another f string with a different kind of quote, and then I will have f string start here and f string start that's kind of nested in here with its own f string middle and end. And nowadays I can even use the same same kind of quote, because these braces make it obvious that, you know, this is nested inside. So there's some magic added into Python 3.12. Well, Pablo added that. There's a pip for it. So the tokenizer itself is actually quite smart in generating these f-string start and end tokens appropriately. And for the docs, what does it mean for the docs? I think ideally this would be documented either in expressions or in formatted string literals, like in the tokenizer section of the docs, because this is really, there's the tokenizing and the actual grammar is really tightly connected here. It's probably what I'll do is take this f string and put it in here. Oh, I don't even know how I'll handle the lexical analysis part of this later. Well, that's a hard problem I can punt on for now, so I'll just leave this here. This string section looks quite self-contained. Maybe I'll add another to-do here. String as top level, and I'll add to do. Oh, I'm still at literals. F string. Right. Now this will be a bit complicated, but mostly just splitting it off into separate sections to make it easier to read, I guess. Right, next up, parenthesized forms. This will have the group and this will have the tuple. It should be fine. Comprehensions. Wait, no, displays for lists, sets, and dictionaries. So there's the old dogs have a comprehension, comp for, comp iter, and comp if. And how does that there should be a generator expression list, list comp, dict set, dict comp, and set comp. Where are those documented here? Oh, they're So there are common syntax elements for comprehensions listed first, and then it goes on to say, you know, list displays are start list comprehension. List displays are built out of this, but with square brackets, and set displays are built out of that, but with curly brackets and so on. I wonder if that's the best way to go around this, because lists and sets are very similar. You know, they just differ in the brackets they use. So I guess it would be easier to follow the documentation if the main section said, you know, here's how you do lists and sets, and then documented these whatever start list, start name expression, or comprehension is used in both of them, and then the list displays and set display sections would just display would just document the semantics of that particular data type. The syntax wise they're identical except for the brackets. And then the docs could go into all this detail about comprehensions. Yeah, that would probably be best. So I'll think about that for later, but for now I'll leave it how it is, because if I move these to the front, then everything is in the right place. I guess star targets are mentioned in assignments before, so that's good. And then dictionary displays, of course, are a bit more involved because they, instead of you know, named expressions inside, they have the colon separated items. So there's double start key value pairs. That's a list of key value pair, and that can be a double start expression or key value pair itself, bitwise, or should really be documented elsewhere, but hopefully it will be. Key value pair expression, comma expression. And then we of course also have a dict comprehension, which is key value pair and then 4 if clauses. So that's almost the same thing here as for set comprehensions. So I guess this is where it belongs, and for now I'll go on. Generator expressions, that's another kind of display. So if you have parentheses and expression and comprehension 4, that will give you a generator expression. And in the actual grammar, the rule is shared with parenthesized expressions, it seems. Oh no, assign an expression, so it's shared with the walrus operator. I'll probably need a bit of explanation. Later. But for now, this is in the right place. I probably can't tease this apart right now. Yield expressions. There's a yield atom. And I wonder if we still have that in the actual grammar. Oh, it's probably used in another way. So we don't have yield atom, we'll just have a yield expression, which is yield from expression, or just yield and optional start expression. So this is a different way of saying this. There's a yield in front, and then we have either from expression or an expression list or nothing at all. Right. So next up, no more grammar here. So, well, coroutines are like the API for coroutines is as described here. It looks out of place, you know. The API of lists isn't described here, but generator iterator methods are. I guess there's a reason for that. It's not my place right now to question it. We get to primaries, most tightly bound operators of the language. So a primary can be an atom, so that's not an operation, that's a single name or something like that, or the list generator and so on. It can be an attribute reference, subscription, slicing, or call. So attribute so there's atom, there's attribute reference, there's a primary generator primary and generator expression. Yeah, this is probably because you can omit the parentheses around a bare generator, around a generator expression if it's the only argument to a function, right? So you can do foo I don't know, x times 2 for x in range about 20. Oh, it's an existing function, so you can do that, but as soon as you add another argument, Python will complain that the generator expression must be parenthesized, right? So you need to parenthesize the generator expression if unless it's the only argument, and that's that has its own syntax rule here. So this is primary, that's the function name, and then there's the generator expression without the function call parentheses, right? Generator expression has the parentheses around it right here, and these parentheses on the grammar level don't actually correspond to the call. They're just around the generator expression. So this is basically the an implementation detail of the call. And then we have subscription, which I guess encompasses both subscription and slicing from the old docs. We'll see that later. So this is fine. Attribute references are primary.name, where primary is again, that again can be another attribute reference and so on. So you can have something dot something dot something, or you can have calls and subscriptions between that. Subscriptions are, well, very similar to this .name. There's primary, and then we have slices. I wonder where slices are defined in here. So what can you put in square brackets when you're indexing? Right, so the old docs has separate entries for subscription with a single thing, and slicing has a slice list with multiple things. It's probably better to unify it like that. And slices then can be quite complex. It can be an expression or slice, so that's sliced or named expression, or it can be a comma-separated list of those. So this is not complex. It's just a comma-separated list of slices or named expressions with an optional comma at the end. But again, probably for performance reasons, there's a special case when there's only one. This could be omitted, and hopefully we can simplify it so that it can be omitted. So slice, named expression, or it can be a start expression. And a slice is an optional expression, colon, optional expression, and then an optional colon, an optional expression. So what does that mean? Slice needs to have a colon in it. It can have an expression on either side, and then it can be followed by colon expression. That makes sense. If it doesn't have the colon in it, it's this named expression here. And this can be starred as well. So you can have star in your attribute, in your item access. That's interesting. So boom. If I have a list, can I do So this will actually give a tuple to the list, probably with one element. Oh, didn't know you could do that. It's probably in some recent, but interesting. Right, so you can unpack sequences when you're indexing. That makes sense. So this is all in its place. And next up we have calls, and this looks, oh, that's very long. That's why it's it looks shorter. Call primary, and then there's an argument list or a comprehension. Right. So in the original documentation, in the existing documentation, call is I guess this makes better sense for humans. It's the function name, and then in parentheses you can have either an argument list or a single comprehension, and this comprehension doesn't have parentheses around it. In the actual grammar, you need to have parentheses around arguments, because if you're using a comprehension, then this rule here applies. Arguments are args with optional trailing comma, and args are comma separated several kinds of expression with an optional comma and keyword args at the end, or it can just be keyword arguments. Okay, start expression is an expression with a start at the front. Keyword arguments are comma separated keyword argument or start, so that's name equals expression, this is the name, the keyword argument, or a start expression here. Okay. And you can have keyword arguments or double start, which instead of 1 star here has 2 stars, or you can have keyword arguments or start. Oh, you can have both following each other, or you can just have one of them. That's a very long-winded way to describe it. What does the original syntax say? Argument list is positional arguments, started on keywords, keywords and arguments, or it's missing these positional arguments, which is a start and keywords, or it's missing both of these and it just has keyword arguments. And again, it's a very long way to say. You can I guess the way it's done, the reason it's done this way is you can't have a comma at the very start of this, right? You can have positional arguments, start and keywords arguments all present, but you need to properly separate them by the comma, and you need to have them in this order, and you can't have a comma at the beginning. And I guess this might be missing the possibility for a final comma. Oh no, you can have a final comma after keyword arguments. Oh, yeah, arguments have a comma at the end. Right, yeah, right. You can have a final comma at the end. That's in the preceding rule, but you can't have a comma at the start. So this is, well, the railroad diagrams might make this easier to follow, but that's the formal way to describe function call arguments. Anyway, we have positional arguments, which are comma separated positional items. Positional item is either an assignment expression or a start expression. So that's this thing. Start and keywords are either start expressions with a star, so this thing, or keyword items. Keyword items is something equals expression. Right, and this is again comma separated, this part. I guess this was written before we had this this special grammar extension to use. Keywords argument are very similar. It has 2 stars, so yeah, looks okay. Everything's in the right place. Let me go on. Await expression can be await primary or just a primary. Running out of this space. Anyway, so this is not just an await expression, but it can also be a normal expression, not the await one. We have the power operator, which works the same way. It has something to the power of something else, but in the actual grammar it can also be this await primary here. Right, so in the actual Python grammar, each kind of expression can either be the actual operation we're looking at, or it can be, I guess, the previous operation described here. Said ignore here. I'm getting a new computer very soon, so I don't care about running out of disk space. Anyway, that should be explained, but I guess the rule is in the right place. Unary arithmetic, so we have power or minus plus, so these are all the unary operators that go before an expression, and instead of uexpr we use factor now. And instead of mexpr we use term. I guess it's a better term than a singular name. So an nexpr used to be documented as a uexpr, so this one, the factor, or one of the multiplication like operands, and now term would be term times factor, so this is multiplication like operators. And we need to have sum here as well, so term and sum now have two rules. Oh well, the mexpr and axpr are term and sum, so let me add sum. Sum to here. So that should then match. So this is plus or minus. Shifting operators. Right, so this is shift expression and then a shift operator and then a sum or just a sum. Binary bitwise operators. So there's this bitwise and it should have the bitwise or XOR. Operators bitwise and, bitwise or, bitwise XOR. So all of those should be defined here. They all work the same way. And then we get on to comparisons, which in the old docs are defined by OR_EXPR. That's this one, comp operator OR_EXPR. And comp operator is one of those. And the actual grammar defines this as bitwise OR and then a compare of bitwise OR pair, or only a bitwise OR. So basically this is optional. Then if this had a star instead of plus, we wouldn't need this other branch. Bitwise OR and XOR should be documented above, and then we have bitwise of bitwise OR pair, which is one of these, and that's always sum operator and then bitwise OR. I guess this is a much better way to say this, but maybe there's some performance reason why it's divided into all these rules. Like why is this whole pair coded as a rule and we don't just have a comp operator? There's probably some reason for that, but everything except this bitwise OR and XOR is in the right place. So let me move on. Identity comparison. So OR test and test not test are now named disjunction, conjunction, and inversion, and they're defined in much the same way, except the branches are in the other order. So in the new grammar, the order matters. So if this matches, that's what it'll parse as, and if it doesn't, then the parser will try a simple inversion. There's one more unary operator hidden in here, but everything's in the right place here. Now we have assignment expression, which is in the old grammar assignment expression. Well, expressions were also assignment expressions. In the new grammar, apparently assignment expression is its own thing. Let's see how that's used in the full grammar spec. So generator expression. So every time assignment expression is used, it's used as assignment expression or an expression without the assignment operator. So every time this is used, it's basically using what the old docs have, but for some reason in the new grammar, it's now not moved out of the rule itself, which I guess is fine. Right, next up, conditional expressions. Or test, that's the disjunction. If disjunction, else expression, so that's the same thing as here. Expression is a conditional expression or a disjunction or a lambda definition. Right, so this part being optional is basically moved into the next rule. That looks good. And named expression is, what is named expression? It's probably a rule I wanted to move somewhere. Oh, named expression should probably be documented with assignment expressions. And that's the assignment expression, and this is the part without the name colon equals. So let's move that. Let's move that up here. That's the right place for it. I'll write the pros for it later. Now lambdas. Lambdas are very simple in the old documentations. Just lambda, optional parameter list, colon, expression. But for some reason in the actual grammar we have special lambda parameters, which are different from normal function parameters, and I have no idea why. But if I'm just looking at whether everything's in the right place, it looks like it is, unless this default is also used somewhere else. I guess Lambda parameters can't use default arguments as freely, or there's some reason like that, where you can use this a simple expression. So maybe what the docs should say is, you know, this is a lambda definition where lambda parameters are the same thing as function parameters, except for this one little difference, which means we have to define them the long way, copy the definition, and include no default rules or something like that. I think that'll be much easier to see when we get to the railroad diagrams eventually. So I'll leave it for now. Everything's in the right place. It's enough for now. Expression lists. So expression list was renamed to expressions. This and this are almost the same thing. Well, this is a long way of saying that's comma separated expressions with an optional comma at the end. So this one, for performance reasons, I guess it's written out. Star expressions. So that's the equivalent of the start list, and again it's written out, but it's comma separated list of star expressions. One star expression is either an expression or start item, and then it can have commas and other start item. Why is this so complicated? Maybe it's because the named expressions are split out from expressions. So we had that somewhere here. So named expression can be an assignment expression or expression. So before that, assignment expression could also be just a simple expression. In the actual grammar, for some reason, they're separate, so they need to be separated here as well, which is sad. But XOR is in the right place, so everything's fine. And I think I'm finally running out of disk space now. Well, either that or Sphinx has an error. Now I'm running out of memory because Sphinx I let Sphinx run in the background and it started using a lot of memory for some reason. Everything got slow. Let's not run Sphinx in the background then. We're done. So, thank you for everybody who watched this on YouTube. I hope it was at least somewhat interesting. I very much hope the next installment will be much more interesting than just going through the docs. Also, if you join the live stream on Discord, where you can ask questions whenever something is interesting for you, that would be much better than looking at YouTube passively. But for today, I am out of time. I will commit these changes, And next time I will choose whether to tackle lexicon analysis, probably not, or whether I'll rewrite the tool to make it a bit closer to what I want in the end, which is rewrite the actual RST files so that the production list is visible in any pull request that changes the grammar. So hopefully next time there will be actual code. But for this week, that's it for me. Thanks for watching. See you next time.